So before we begin writing any code, let's take a look at the big picture stuff around microservices and what microservice architecture enables us to do. And it effectively enables large teams to build scalable applications that are composed of many loosely coupled services. And what does this architecture look like, and when should we use it? So our services are loosely coupled. Each service handles a dedicated function inside a large-scale application. So for example, in our case, we will have an auction service that handles REST-based API CRUD operations, a search service, which obviously handles search functionality, and a bid service to handle the bids for an auction. We will have more services, but each of these services all can be individual microservices. And the idea is that each microservice does one thing, and it does it well. Also, each microservice is going to be responsible for its own data. We do not share databases between our different microservices. But these are separate services. They're not separate applications that don't have any reliance on the data that's contained with a different service. So that means they need to communicate with each other. And there are approaches to doing so. They can either communicate directly with each other via protocols such as HTTP, which I'm sure we're all familiar with, or more commonly for direct synchronous communication between services, then we would use something like a remote procedure call or gRPC, which is fast communication between our services. But one of the goals of a well-designed microservice is that it should be autonomous. And if we lost service A, and service B should really be unaffected by that loss of that service, and it should still be able to operate and respond to any request that it receives. So whilst we can use that approach to communicating between our services, more typically we'd use something like a service bus, which allows us to make fire and forget asynchronous communication between our two different services. And microservices is not an easy way to build an application, so we need to focus on the benefits it gives us. And one of the benefits is that we can survive a failure of one of our services and it should not impact the rest of the services. So we want to aim to design our application in such a way that our services can communicate with each other, but a failure of one does not impact the rest of our application. And by designing it that way, and to have our services as these small, loosely coupled services that are easy to reason about because they do one thing and one thing well, then this gives us peace of mind to make changes to our individual service as a team of developers and deploy often, independently of the other services that make up the application as a whole. So another goal of a microservice architecture is we should be able to deploy each service independently of any other services. We do not need to deploy our entire application anytime a change has made in a single service. And another reason for microservice popularity nowadays, and one of the reasons it's become a trendy buzzword and the thing to go to when creating a new large application, is its ability for us to be able to scale each service independently of other services. If our search service was particularly busy, we could scale that independently of the other services. Or if one auction or an auction was having thousands of bids at the same time, then perhaps we'd want to scale that one individually so that it can cope with its load, without necessarily needing to scale the other services. And that's one of the downsides to a monolithic approach, is you do not have that flexibility. You can only scale horizontally, which means you make copies of the entire application and run them on different servers, or you scale vertically, which means you make your server much, much bigger, which isn't really practical. So it all sounds good, but then we need to think about what the difference is between this and a monolith. Now, in a monolith, we typically have one single database, and that database would be responsible for maintaining foreign key relationships between our different tables in that database, and it would be responsible for enforcing referential integrity between those functions or units of our application. But in a microservices architecture, each service has to be responsible for its own data, and now the burden of maintaining that data integrity is now shifted onto the application layer rather than the database layer. So that is something else that we need to think about when it comes to building our services. How do we maintain data consistency and integrity between them? And that's the part where microservices becomes significantly more complex than a monolithic architecture. A couple of other components I want to mention that make up a microservice-based application that you would not see in a monolithic application is we would need something like a gateway that receives requests from our client applications and is responsible for forwarding and transforming those requests to the different services inside our app. And would also have something like an identity provider that sits outside of our microservices application, and our gateway could check with the identity provider to make sure that the request is valid and authenticated before forwarding it on to each individual service. Another downside to microservices is that it is not the cheapest way to build an application. Each one of these individual services and their corresponding databases does cost money, and more money than it would be to build a monolithic application. So this approach is not really suitable for small teams. It would cost more money and it would take longer to build the application this way. We're really looking at something here that's designed for large teams so that they can operate independently of each other, and by building these services independently and small, well designed, do one thing well kind of service, then each individual team can operate simultaneously or concurrently on those different services, and it can enable the application to be built faster so long as each team can operate independently of each other and not rely on another team's functionality before they can get on with building theirs. So good for big teams and big organizations, not so good for small teams and small organizations. But anyway, that's just a taster of microservices that I wanted to introduce, and over the coming lessons we're going to implement this kind of functionality to build our app. Okay, welcome to section 2, the first coding section in this course, where we go ahead and create our first microservice in our microservices application. And in this section we're going to start off by creating a simple API for the auctions, and it's going to be a simple CRUD application. Now, the complexity in this application is going to be the microservices themselves and not the code internally inside those services. We're going to keep them as simple as realistically we can, and we're going to start off by building a CRUD application. We need our users to have the ability to create, read, update and delete auctions in our auction style application, and that's what we're going to create for our first service. So we're going to take a look at things like adding those API endpoints, and we're going to be seeding some sample data into our database. And the database technology that we're going to be using on this course is Postgres, or in this service it's going to be Postgres. Now, I would highly recommend that you use Postgres and not something else. Later on in this course there are things or features that we'll use that we can only use with Postgres or one other, but not SQL Server at the time of recording, and it will make your life more complicated and challenging in a course that is already probably complicated and challenging, to make it even more complicated and challenging by using something different to myself regarding the database technologies. So please do use Postgres database, even if you have the ability, because you're on Windows, to use SQL Server, as we're going to be using later on a feature that's only available with Postgres at the time of recording. Now, we're also going to be taking a look at Docker Compose to get our Postgres database up and running. So Docker is a requirement for this course. You will need to have Docker installed, running and available pretty much all the way through this course, and that is a requirement for it as well. We have to use this, even though Docker is not microservices and microservices is not Docker. It would be highly unusual to create this type of application without taking advantage of the functionality that Docker gives us to containerize or Dockerize our different services and have an easy way to get them started, stopped, whatever we're doing. So we are going to heavily use Docker in this course as well, and we're going to start off by getting Postgres up and running, and we'll be using a tool from Docker to do that called Compose, and that's how we're going to be running our services whilst we're in development mode. Also, Postman is something else that we're going to be using extensively in this course, so please do have this installed and available as well. And even though there's other ways to test your API, maybe you like to use Swagger, maybe you've got a different tool in mind for testing API endpoints, please do use Postman, because I have provided a pre-built Postman collection that contains various tests inside it and also checkpoints as well, so that as we go about building our whole application at certain phases, there'll be checkpoints just to reassure ourselves that what we're doing is correct as we go along, so that we don't run into a problem later on related to something we do early on. We'll know that if our checkpoints pass, then we're on the right track, and the later functionality that we also add will work as well. So we're also going to be using Postman in this section. Now, just to highlight the overall picture, and I'll reintroduce this slide as we go along, just so that we know where we stand as we build the application. We're starting here with the auction service, and we're going to have an auction service web application or a web API with .NET, and it's going to have a Postgres database to persist the data. And obviously we've got a lot more to build, but this is where we're starting, and I'll refer back to this diagram quite often as we build our different elements that we're creating for the microservice application as a whole. And also for each service or .NET service that we're building, I've provided a specification so that we're aware of the different types of things that these services are going to support. And also you get this from the course assets folder, so if you do not have that already, please go ahead and download that. And with this gives us this course assets folder. Inside here is various folders that contain the Postman collection, snippets, and also in the specs folder we have the specifications for different services. And if I open up the auction service specification, just to give you a brief overview, I'll talk about this in the next lesson anyway, but this is something that I'll be referring to, so please do get the course assets folder from the lesson entitled Course Assets and Source Code if you do not already have this. Attached to that lesson as a resource is something you can download, and it'll be a course assets zip file which you can extract, and it will give you this stuff. So do ensure you have this before you move forward, because I will refer back to it on multiple occasions during this course. So now we've looked at that, we're ready to go. So let's begin creating our first microservice.